This video is made by Nihar Dash from YouTube. This video is made by Nihar Dash from YouTube. One technology of television. The technology of television has evolved since its early days using a mechanical system invented by Paul Gottlieb Nipkow in 1884. Every television system works on the scanning principle first implemented in the rotating disc scanner of Nipkow. This turns a two-dimensional image into a time series of signals that represent the brightness and color of each resolvable element of the picture. By repeating a two-dimensional image quickly enough, the impression of motion can be transmitted as well. For the receiving apparatus to reconstruct the image, synchronization information is included in the signal to allow proper placement of each line within the image and to identify when a complete image has been transmitted and a new image is to follow. While mechanically scanned systems were experimentally used, television as a mass medium was made practical by the development of electronic camera tubes and displays. By the turn of the 21st century, it was technically feasible to replace the analog signals for television broadcasting with digital signals. Many television viewers no longer use an antenna to receive over-the-air broadcasts, instead relying on cable television systems. Increasingly, these are integrated with telephone. To display technology, digital video equipment and an edit suite. There are now several kinds of video displays used in modern TV sets. CRT, cathode ray tube. Up until the first decade of the 21st century, the most common screens were direct view CRTs for up to roughly 100 centimeters, 40-inch, in 4:3 ratio, and 115 centimeters, 45-inch, in 16:9 ratio, diagonals. A typical NTSC broadcast signal's visible portion has an equivalent resolution of 449 x 483 rectangular pixels. Rear projection, RPTV, displays can be made in large sizes, 254 centimeters, 100-inch, and beyond, and use projection technology. Three types of projection systems are used in projection TVs: CRT-based, LCD-based, and DLP, reflective micromirror chip-based, DILA and LCOS-based. Projection television has been commercially available since the 1970s, but at that time could not match the image sharpness of the CRT. A variation is a video projector, using similar technology, which projects onto a screen. This is often referred to as front projection. Flat panel display, LCD or plasma. Flat panels television sets use active matrix LCD or plasma display technology. Flat panel LCDs and plasma displays are as little as 25.4 millimeters thick and can be hung on a wall like a picture or put over a pedestal. Some models can also be used as computer monitors. LED, light-emitting diode, arrays, not to be confused with the LED backlighting used behind some LCD panels, consequently advertised as LED, became the favored technology for large outdoor video and stadium screens after the advent of very bright LEDs and the matrix driver electronics for them. They make possible ultra-large flat panel video displays that other technologies are currently not able to match in performance. OLED, organic light-emitting diode, technology is currently, 2019, used in high-end smartphone screens and televisions. Unlike LCD panels, OLED screens are viewable from extreme angles, are free from pixel lag, and offer a very high contrast ratio comparable to CRT displays, with very deep blacks. They can be extremely thin and lightweight and can, at least in prototype, be made flexible enough to roll up when not in use. Each has its pros and cons. Front projection and plasma displays have a wide viewing angle, nearly 180 degrees, so they may be best for a home theater with a wide seating arrangement. Rear projection screens do not perform well in daylight or well-lit rooms, and so are only suitable for darker viewing areas. Three terminology and specifications. Display resolution is the number of pixels of one row on a given screen. Before the year 2000, horizontal lines of resolution was the standard method of measurement for analog video. For example, a VHS VCR might be described as having 250 lines of resolution as measured across a circle circumscribed in the center of the screen, approximately 440 pixels edge to edge. With analog signals, the number of vertical lines and the frame rate are directly proportional to the bandwidth of the signal transmitted. A typical resolution of 720 x 480 or 720 x 576 means that the television display has 720 pixels across and 480 or 576 pixels on the vertical axis. The higher the resolution on a specified display, the sharper the image. Contrast ratio is a measurement of the range between the lightest and darkest points on the screen. The higher the contrast ratio, the better looking picture there is in terms of richness, deepness, and shadow detail. The brightness of a picture measures how vibrant and impacting the colors are. Measured in candela per square meter, CDM2. On the other hand, the so-called brightness and contrast adjustment controls on televisions and monitors are traditionally used to control different aspects of the picture display. The brightness control shifts the black level, affecting the image intensity or brightness, while the contrast control adjusts the contrast range of the image. For transmission band, there are various bands on which televisions operate depending upon the country. The VHF and UHF signals in bands 3 to V are generally used. Lower frequencies do not have enough bandwidth available for television. Countries with 60 Hz power line frequency use frame rates very near 30 per second, while 50 Hz regions use 25 frames per second. These rates were chosen to minimize the distortion of pictures that could be produced in analog receivers. For a given frame rate, an analog signal with 400 lines per frame would use less bandwidth than one with 600 or 800 lines per frame. Higher bandwidth makes receiver design more complicated, requires higher radio frequencies to be used, and may limit the number of channels that can be allocated in a given area. The same radio frequencies useful for television are also in high demand for other services such as aviation, land mobile radio, and mobile telephones. Although the BBC initially used band I VHF at 45 MHz, this frequency is, in the UK, no longer in use for this purpose. Band 2 is used for FM radio transmissions. Higher frequencies behave more like light and do not penetrate buildings or travel around obstructions well enough to be used in a conventional broadcast TV system, so they are generally only used for MMDS and satellite television, which uses frequencies from 2 to 12 GHz. TV systems in most countries relay the video as an M, amplitude modulation, signal and the sound as an FM, frequency modulation, signal. An exception is France, where the sound is M. 5. Aspect ratios. Aspect ratio refers to the ratio of the horizontal to vertical measurements of a television's picture. Mechanically scanned television, as first demonstrated by John Logie Baird in 1926, used a 7:3 vertical aspect ratio, oriented for the head and shoulders of a single person and close-up. Most of the early electronic TV systems, from the mid-1930s onward, shared the same aspect ratio of 4:3, which was chosen to match the Academy ratio used in cinema films at the time. This ratio was also square enough to be conveniently viewed on round cathode ray tubes, CRTs, which were all that could be produced, given the manufacturing technology of the time. Today's CRT technology allows the manufacture of much wider tubes, and the flat screen technologies, which are becoming steadily more popular, have no technical aspect ratio limitations at all. The BBC's television service used a more squarish 5:4 ratio from 1936 to 3 April 1950, when it too switched to a 4:3 ratio. This did not present significant problems, as most sets at the time used round tubes which were easily adjusted to the 4:3 ratio when the transmissions changed. A Samsung LE26R41BD. In the early 1950s, movie studios moved towards widescreen aspect ratios such as CinemaScope in an effort to distance their product from television. Although this was initially just a gimmick, widescreen is still the format of choice today, and 4:3 aspect ratio movies are rare. Yet the various television systems were not originally designed to be compatible with film at all. Traditional, narrow screen movies are projected onto a television camera either so that the top of the screens line up to show facial features, or, for films with subtitles, the bottoms. What this means is that filmed newspapers or long captions filling the screen for explanation are cut off at each end. Similarly, while the frame rate of sound films is 24 per second, the screen scanning rate of the NTSC is 29.97 Hz per second, which requires a complex scanning schedule. That of PAL and SECAM are 50 Hz, which means that films are shortened, and the sound is off-key, by scanning each frame twice for 25 per second. The switch to digital television systems has been used as an opportunity to change the standard television picture format from the old ratio of 4:3, 1.331, to an aspect ratio of 16:9, approximately 1.781. This enables TV to get closer to the aspect ratio of modern widescreen movies, which range from 1.661 through 1.851 to 2.351. There are two methods for transporting widescreen content, the most common of which uses what is called anamorphic widescreen format. This format is very similar to the technique used to fit a widescreen movie frame inside a 1.331 35mm film frame. The image is compressed horizontally when recorded, then expanded again when played back. The anamorphic widescreen 16:9 format was first introduced via European PAL Plus television broadcasts, and then later on widescreen laser discs and DVDs. The ATSC HD TV system uses straight widescreen format. No horizontal compression or expansion is used. Recently, widescreen has spread from television to computing, where both desktop and laptop computers are commonly equipped with widescreen displays. There are some complaints about distortions of movie picture ratio due to some DVD playback software not taking account of aspect ratios, but this may subside as the DVD playback software matures. Furthermore, computer and laptop widescreen displays are in the 16:10 aspect ratio both physically in size and in pixel counts, and not in 16:9 of consumer televisions, leading to further complexity. This was a result of widescreen computer display engineers' assumption that people viewing 16:9 content on their computer would prefer that an area of the screen be reserved for playback controls, subtitles or their taskbar, as opposed to viewing content full screen.